So let's go over the pipes that are used in an irrigation system. And we'll talk about different materials that can be used as pipe. And we'll talk about which ones are commonly used here in Southern California. And within that, how do you select the pipe and what's going on with all those different numbers and those different letters? Okay, so ultimately, just keep in mind that the pipe is a circle that's been elongated. It's a cylinder, and it's the most efficient way to have water transported. If there was a better shape, it would be shaped differently. But a pipe is as best as we got, and basically it's a tunnel. And in the really old days, they had clay pipes and all sorts of other wacky things, wooden pipes even. But now we use modern materials. Copper pipe is perhaps the most classic type of pipe to move water in our common era. So this is used for a lot of plumbing inside of the house. And now we're starting to see it be replaced with some plastic that's meant for indoor purposes. But copper is quite durable and lasts a long time. It resists corrosion, and it's relatively easy to fit it together and get it to permanently stay in place. So there was a time when copper was the most common type of pipe to use on sprinkler systems outside as well, but it's relatively expensive. The prices of materials have changed so much in a relatively short amount of time that it has affected what are the most popular uses of material. So you may still find some older neighborhoods where copper is primarily used for like a main line in the ground. And sometimes going from the water meter to the house is all in copper in an older neighborhood. And if you want to create a point of connection, you'll need to learn how to cut and solder copper pipe. In order to prevent it from leaking, we use a type of welding called soldering, where you use the torch and you use a little bit of material to fill in the gaps, melts it all together, and you've got a water and airtight length of pipe that is quite durable. It's a little bit more permanent than our PVC pipe, which is easier to work with. And so we've largely abandoned copper pipe for cheaper materials. There was a time before cheap plastic when galvanized steel was much more commonly used in irrigation. And you will still see galvanized steel pipe for irrigation on large commercial applications, mainly in older neighborhoods, 70s and 80s, constructed HOAs, especially up on hillsides where they installed irrigation once upon a time. They often left the galvanized pipe above ground, and you can go out and see it. So, of course, this is very durable pipe, as it doesn't break very easily, but its durability makes installation difficult and expensive, and things need to be threaded and cut, and it takes a long time. And so today we don't use galvanized steel for the majority of irrigation, but we will still use it for certain risers that need to come up above ground because they're so durable, and maybe some really large-sized, heavy-duty equipment makes more sense to put on galvanized steel pipe than it would to put on plastic pipe. Plastic pipe does not support vertical weight very well, and steel does. So every now and then you use steel, but both copper and steel have pretty much all been abandoned for plastic pipe. So plastic pipe came around in the late 50s and early 60s, and it's become more and more affordable since then. It is relatively inexpensive. It's very easy to install, and it's quite smooth. And being smooth gives good water flow characteristics. There are two main types. The first type is polyethylene, and then the second type is polyvinyl chloride, or PVC. So the polyethylene pipe is primarily used on drip irrigation, It's soft and moldable and very easy to install, but what you gain with ease, you lose with durability. So because it's more flexible, it's easier for it to come undone, and you often have issues with animals breaking into it or little pieces getting clipped and snipped easily, and you need more repairs. The PVC, on the other hand, is the most common use of materials for irrigation in Southern California. Uh, Mainly, we dig a trench and put the PVC pipe underground. We don't have to worry about freezing, and so the fact that it does not expand doesn't cause us any issues. And it's much more durable than the lighter PE pipe. You go to other parts of the country, though, and PVC is not easily used because of the freezing factor. You may want to go with polyethylene, which can actually give a little, can expand. And other places where the soil is really rocky or where you work around lots of trees, many times they use a flexible PE pipe instead of a PVC because there it would just be too difficult to have. You'd be having fittings all over the place, and instead you can snake your pipe around obstacles. But here in Southern California, it's our code. It's the standard that we use PVC for the vast majority of our pressurized and even semi-pressurized after the valve pipe. So here's PE pipe, and some of the fittings that you can see are up above. A lot of them are compression fittings, meaning you just literally push them in together, and there's little barbs and little mechanisms that make it so they resist coming undone. That's nice because you can just install it in the field with no special equipment. And as long as you know what you're doing, you plug it all together and it's good to go. We primarily use it for drip irrigation. And oftentimes it's black in color, although it could also be purple or brown, or it comes in many colors. Usually you see it in black. The nice thing about this type of pipe, because it's flexible, it can be rolled up. And so you can store a very long length in a very small space. And that is a really nice handy feature. And if you're installing it, you can even keep it on the roll and you can snake it along and uncoil it as you go. And it makes it quite convenient for installation and storage. However, because it's thinner, typically in material, it's usually rated for low pressure applications. And this is especially true for our drip systems, which often can be needed to be down 20 to 30 psi. If you plugged up a drip system to a 90 or 100 psi water pressure, without a pressure regulator, you likely would have either instantaneous break, or you'd be having so many breaks that it would be not practical to use that pipe. So a little bit more durable would be PVC. And PVC is the primary pipe that we use for sprinkler irrigations in this region. It's easy to cut and glue and install. Now, when you glue it, technically you're not using a glue, although it works like a glue and everyone calls it glue. You're actually applying a solvent weld. So you're dissolving the plastic, and when you put two pieces together that have been solvent welded, they melt themselves together and form one single length of plastic, where actually it's stronger at the connection than it is at the pipe itself, as long as your solvent weld is a good weld. So PVC has a lot of pros. The pros are that it's cheap, it's affordable, and it's relatively durable for the ease of installation. Usually it's white in color, although it can come in gray or purple as well, based on different sizes and different applications. One thing about PVC is it's not good for ultraviolet light. So it's not good to be kept exposed to the sun. And if you are going to have it exposed to the sun, you're supposed to paint it to keep the UV rays off of the pipe. And otherwise, underground, it's just fine. It's much more durable. If it's left out in the sun and exposed to UV rays, it tends to become brittle and much easier to break. If it's properly installed, it can last for 50 years or more. Oftentimes, though, you'll see good irrigation systems built with PVC lasting about 25 or 30 years. 50 years is, you won't see the pipe get damaged too often, but you'll probably see your fittings and your connections break. PVC is sold in two different sizing categories. One was designed for irrigation, and the other was kind of stolen from the previous generations of pipe, and it's more along the lines of plumbing and engineering. And so we'll talk about those two different sizing categories. So the first category of PVC pipe is called schedule PVC pipe. And that's referring to the thickness. And it's based on an older galvanized pipe system. You can see the image on the right-hand side shows a Schedule 40 pipe compared to a Schedule 80 pipe. And notice that the Schedule 80 is twice as thick as the Schedule 40. Those two dimensions, Schedule 40, Schedule 80, those are the most common thicknesses of PVC pipe in the schedule system. The thing about the schedule pipe is that the thickness is relatively constant as you go up in diameter. So your half-inch pipe, your 3/4-inch pipe, and your 1-inch pipe would all be the same thickness if it's Schedule 40. From a materials perspective, it's much more convenient to be able to produce Schedule 40 because it's all going to be uniform thickness, but there's a downside. The downside is that as you go up in dimension, the ratio of water in the pipe to thickness of the pipe changes. So the larger the pipe size, you'll end up with much more water in that pipe. And as you go up, the pressure rating will go down. So the more water you have in the pipe, the thicker your pipe wall should be in order to compensate and hold water at the same pressure. So the challenge with schedule PVC pipe, although it's by far the most common because it's kind of the old school standard, is that your pressure rating changes as you go up and down in dimensions. So here we see Schedule 40 PVC. It is thick-walled pipe. It's frequently used as the mainline pipe from the point of connection to the valves. It's used in high-pressure situations downstream of the valves if you are in areas of high vandalism or if it's likely to be broken. A lot of people think Schedule 40 is just always going to be stronger than any other type. But remember, it's only stronger when you're in the lower pipe sizes. As you go up in size, say to a 6-inch pipe or higher, then that Schedule 40 thickness is going to look awfully thin compared to the overall diameter of the pipe. And so the schedule system works well for irrigators because we're typically on small dimension pipe unless we're doing golf courses or large sports fields. But ultimately, it's what the vast majority of residential and small scale commercial irrigation systems use. Schedule 80, therefore, is twice as thick as Schedule 40. It is typically used where you have threaded fittings and components because to cut those threads into the plastic is to remove some plastic. And so you could have a Schedule 40 fitting that is threaded, but it's no longer Schedule 40 in thickness because those threads have cut out material. So if you're going to use a threaded fitting, oftentimes a thicker material is more worthwhile so that you have the proper thickness at the thin parts. And so we would use Schedule 80 for that. And also for any point where you need a little bit extra thickness or sturdiness. So many times when we attach to the valve, we use a Schedule 80 length of pipe, and it could either be threaded or solvent welded to the valve itself. Commonly, it's sold in a dark gray color for irrigation. You may find it in other colors, and it may also be used for electrical conduit as well, Schedule 80 PVC. But now let's look at the class system of pipe sizing. It's actually a little bit more sophisticated, and it's and it's a little bit better for irrigators to use just because it's a bit easier. The problem is we don't use it very often, and it's a lot of times kind of misunderstood, so it has a bad name. So the problem with schedule pipe is that as the pipe diameter gets bigger, the pressure rating decreases. And so it can be hard to remember what is the pressure rating for this schedule pipe for this particular size. So a new system was developed called the class system, and basically the number is the pressure rating. So if you get class 200, for instance, that is pipe that is rated for 200 psi. And you can get class 200 in ½ inch, or you could get class 200 in 1 inch. And the thickness of the pipe will change based on the pressure rating of that volume of water inside the pipe. So it's very handy for irrigation designers to specify the class system, because you can do all your pressure calculations and you can make sure you're within the maximum allowable pressure at any given length of pipe. The problem is that oftentimes you try to get away with the least amount of material possible. So a class 200 pipe on a small diameter pipe is a very thin wall. And although it will work under normal operating conditions, there's a much higher likelihood of a break than with a Schedule 40 length of pipe. Schedule 40 for irrigation oftentimes is overkill. It's too much plastic. It's just kind of not necessary. But the added benefit is that it's going to be much more resilient and resist breaking. And if there's any shovels that hit it, or if there's people digging, or if there's a water hammer in the system, then my Schedule 40 will resist breaking. So oftentimes you'll see designers specify the class system, and then the installers will ignore it and go with the schedule system. And that both have their merits and both have their reasons. And in my personal opinion, the class system is superior, but you should not choose a low pressure rating, especially at small diameters. It's worth it to pay for the extra plastic to keep your system in good shape. The two main classes of PVC that are used in irrigation are class 315 and class 200. 200 is so thin, it's what a lot of people call eggshell pipe, because you just barely tap it and it seems to break no matter what. And so most people would go with 315 based on whatever pressure you have in your irrigation system. It just gives you a little extra security. So we even can go down as low as class 160. It can be used in low pressure situations downstream of the valve. You may ask yourself, why would I go that low ever if it's going to be more easy to break? Well, the answer is that it's cheaper. Less plastic, it makes for cheaper materials. And if you're doing a small scale installation, well, that's not going to be a big difference. But say you multiply everything by 10 or by 100, well, there's a significant cost savings that can start to build up. But with class 160, it is so thin that most professionals feel like it's not reliable. And even if you accidentally drop the pipe itself can break. And so it is good for 160 psi, but even the installation is going to give you potential problems. Class 200 is normally used for 3/4 inch and above. Larger pipes means that the wall is going to be thicker, but as you go down in size, you're going to get down to such a thin wall of pipe that, again, you run into the same problems where it can break easily, even with just minimal increases in pressure, and with the working in and around the pipe itself cause breaks. So class 315 is where you'd go for the higher pressure situations. And if you were going to go down to a ½ inch size of pipe, then certainly you would need to do class 315 as the minimum thickness, because with class 200, ½ inch just is too thin, very easy to break. A lot of times, again, the designer will specify a ½ inch pipe, but the contractor will put in a 3/4 inch pipe, because you don't necessarily lose out on pressure loss by going up in pipe size. It's more than anything just a waste of materials. And it's easier and cheaper to keep only 3/4 inch on hand and keep it on the truck than have to keep a whole bunch of 1/2 inch fittings and pipe. In our irrigation design class, we have the opportunity to explore when it's appropriate to use 3/4 inch and when it's appropriate to use 1/2 inch pipe. So here's a graphic representation that compares all the different schedule and class pipe sizes. Let's take a look on the right-hand side at the schedule system. We have schedule 40 and schedule 80. Notice that as you go up in pipe size, the thickness of the line stays relatively constant. The other thing to pay attention to is the OD and the ID. So OD stands for outside diameter, and the inside diameter is ID. So the difference is your thickness in your pipe wall. Now, if you compare schedule and class, all of the outside diameters are supposed to be exactly the same. So that way we can use them in the same irrigation system and have all the fittings connect to each other. It's the outside diameter that matters the most. Now let's take a look at the class system. Notice for class 160, it doesn't even go below 1 inch because you shouldn't ever do that. And then class 200 and 315 gets down to lower pipe diameters. Now look at class 315 and compare the 1/2 inch thickness of the pipe wall to the 1 1/4 inch. Can you see how the pipe thickness increases as you go up in size? Maybe a little bit difficult to tell with the graphic, but that's what's happening. As you go up in size, the pipe thickness increases. Now let's look at class 315 and compare it to schedule 40 for 3/4 inch. The outside diameter of both pipes is 1.05, and the class 315 has a thinner pipe wall. So what that means is that the inside diameter is going to be larger on the class 315 than it will on the schedule 40. Now, if you receive an irrigation that tells you to put in class 315 or tells you to put in schedule 40 and you mix and match, you put the wrong size, it will all fit according to the outside diameter. But do you see how you will be altering the amount of water that can flow through that pipe, and therefore potentially the pressure as well as the friction of water in that pipe? So if you receive a design and it tells you to install pipes a certain way, I recommend sticking to the design and installing it exactly the way they tell you to do it, because an inside diameter difference of a small amount could potentially have an efficiency impact on your irrigation system. It won't work as well, and it may be likely to break sooner. So all these pipes have their own little intricacies. They have the proper application. And if you get into irrigation design, you'll learn when is the right time to apply all of these different things. It's mainly based on a pressure rating and what's your maximum expected pressure. And if you can make sure you're always well within that maximum pressure, then you want to have as little plastic as possible because that saves you money. So here's a table that lays it all out, and we're looking at different pipe sizes going down on the left hand. And then the columns are based on different thicknesses of pipe wall or different material sizes. And so the numbers that are in each box are the pressure ratings in PSI. So let's take a look at class 315 because that's the first class that is appropriate for a 1/2 inch pipe size. Notice as you go down the column, the maximum PSI is 315 all the way down. Whether you're a 1/2 inch, 1 inch, up to a 6-inch pipe, your maximum allowable pressure will be 315 PSI. Let's compare that to a schedule 40 pipe. So at schedule 40, a 1/2 inch pipe is going to be 600 PSI. Now you go up to 3/4 inch and you're going to be able to withstand 480 PSI. So do you notice how the Schedule 40 is going to be thicker at 1/2 inch and 3/4 inch than the Class 315? But notice as you go up in pipe size, you go down in allowable pressure. So where is the break-even point? It's 2 inches. So if you are going to put in a 1.5 inch pipe size, Schedule 40 is still going to be stronger than Class 315. But once you get to 2 inch and above, Class 315 is now going to be stronger than your Schedule 40. So Schedule 40 is not always stronger than the class system pipe. So you take a look at your Schedule 80, and you can see that Schedule 80 gives you a much higher pressure rating than Schedule 40. But then if it's threaded, it drops the pressure rating down, and it makes it almost comparable to a Schedule 40 pipe. So although most people tend to use the schedule system because it's just easier to think to yourself, oh, Schedule 40 is the thick stuff. That's the stuff you should use. That's really only true when you're below 2 inches. And if you're going to be true to the pressure needs of the system, the class pipe sizing is much easier to follow, and it takes a lot of the math out of the system. You don't have to worry about changing pressure ratings as you go. But you do want to make sure that you don't size it so that you're ever going to exceed those pressure ratings, because at the 1/2 inch and the 3/4 inch size, your pipe wall gets so thin that you have the chance to break it easily. So there you go. I hope you found that useful as we're talking about pipe. It kind of clears things up a little bit. And when you are installing your pipe and your fittings, you'll have a little bit greater understanding of what it all entails.